So whenever we're looking at, I said, all of the companies in the country that sell things are going to have customers, right? They might refer to them as partners or some other sort of terminology, but we all have these same basic entities when we have a given function for our company. But yet, we can still see many, many different database designs for those same entities. And that's a good thing because that gives us the creativity to set things up the way our company needs them. But no matter what we do, we want to make sure that we try to stay as simple as possible. So we're not complicating the world and trying to make things even more difficult for others. Okay, so we've seen a lot about these relationships where we're saying that, you know, an order has to have products that were ordered and a customer that did the ordering. So those relationships exist in the real world and we have to emulate them in our database definition. Here's some nice definitions for us. Characteristics of a relational table. First of all, a table is perceived as a two-dimensional structure of rows and columns. So notice that's just our perception. That's how this table has been represented to us and visualized to us. It's actually disparate data saved out on a disk drive that's brought together for our view to give us that perception. Now, each table row or tuple represents a single entity. Each column represents an attribute, and each column has a distinct name. Each intersection of a row and column represents a single data value. All values in a column must conform to the same data format. So for number 5, we're talking about, you know, the field police. If it's a date, then all of the data in that column must be a date. We can't just have this Joe Smith column where our users say, no, I just really need you to type something in there different, like Joe's going to become active on 10/1. No, we only take a date. So that's its attribute domain. What is the domain of acceptable values? The order of the rows and columns, how we put things on our table, doesn't matter. That only kind of matters to us. We like seeing the most important columns first, getting to the least important, but that doesn't matter. It's totally just however we want it. And each table, they say must have, it's just really highly recommended that we have an attribute or combination of attributes that uniquely identify each row. So if I'm looking at a student table, I'm going to assign a unique student ID to every student. And that's going to be my unique data element that uniquely identifies each row. Whenever we're looking at that unique data element, that's going to be considered a key. So a key could be any sort of attribute that defines something. If I'm looking at a student, their last name could be a very important key field depending on what I'm doing, but it's not necessarily unique to that student, right? But it's still an important key field. So there's a difference there. We can have keys that are not unique, but we still need that unique key to identify each row. We can use our keys then to establish relationships among the tables. That unique key is usually called our primary key. So our primary key is the one that uniquely identifies this individual row, this individual student. Now they have another video that is keys. Let's see what they say. I'm everywhere here, sorry. Visualize. Let's see what they say.
In this video, we'll take a brief look at primary keys and foreign keys. A primary key is an attribute or combination of attributes that uniquely identifies any given row in a table. For example, in the student below, student number is the primary key. Note that a student's last name, stu L name, would not be a good primary key because several students have the last name Smith. Even the combination of last name and first name, student F name, would not be a good primary key because more than one student is named John Smith. Formally, there are two important requirements for the primary key. First, all primary key values must be unique. Second, no part of the primary key may be null. A foreign key is the primary key of one table that has been placed into another table to create a common attribute. Unlike primary keys, foreign...
What is null? No value. So if we're saying that something is a primary key, it has to have a value for us to create a row.
Keys may contain duplicate values and may contain nulls. In this figure, the primary key of vendor, VIN code, was placed in the product table. Therefore, VIN code is a foreign key in product. One advantage of using a proper naming convention for table attributes is that you can identify foreign keys more easily. For example, because the student table shown here used a proper naming convention, you can identify two foreign keys in the table, department code and prof num, that imply the existence of two other tables in the database, department and professor, related to student. This concludes our presentation.
Okay, and then the other video. Now this David Fountain guy keeps messing with his video, so I hope this is the right one. We shall see.
Hi, I'm the Database Management System, DBMS to my friends, and I'd like to explain to you why you should use keys in your databases. Before I explain what the keys on this class table can do, let us look at why we need keys in the first place, by having a look at some records in the students table. Hi guys.
Hi, Mr. DBMS.
Let me just check that everyone's here. Max?
Yes, Mr. DBMS.
Joe?
Yes, Mr. DBMS.
And that's our problem. I cannot tell which Joe is which just by using his name. I need something that is guaranteed to be unique. And with millions of students around the world, I just cannot use everyday information such as their names to be certain I've got the right student. I need to find something that will be different for each and every student. Sometimes there will be a unique field, but for now, I'm going to give each student an ID number. This is something I can control and therefore can guarantee to be unique. This is the secret to making sure I don't mix up one student with another, and it's going to be my primary key. If I know the primary key for this table, I can be absolutely certain I have the right record. Each student gets a different key value. As you can see here, only the right key value will let me get at the right student's record. Keys are useful because they stop me mixing up one student with another, but they get even better when we use them in other tables. Let's have a look at the classes table. Does that look like two copies of Joe's key on those two records? Yes, they are. And because I know they are student keys, I can use them to go back to the student table and look up anything about Joe that I might need. These copies can appear in many records on this table. When a key is used like this, not in its own table, it is called a foreign key. I like to think it has travelled far from its own home, is on holiday. In this class table, can you see that Joe, with the pink key, is taking two classes? Now what about those other keys? They are different from the student ones, and that's because they are keys for the teachers. If you want to find out more about those teachers, we need to look for those key values on the teachers table. So which teacher has the yellow key? Who has the yellow key?
I do. I'm Mr. Smith. I'm a science teacher. I've taught here since September 2006. I'm married with...
Thank you. That's quite enough information for the moment.
You know how teachers are.
And once we know the key value, we can use it to get all the information we need to from the table where it is the primary key. Putting this key value into other tables as a foreign key means we can keep all the information about Mr. Smith in one place and then just use the key to look it up when we need it. So to summarize, a primary key is a unique value in its own table. If the key is then used in other tables, it's called a foreign key.
His finger just went through that table, did you see? Very good. So I like the way Mr. Fountain explains those key relationships in his 3D-ness. So we can uniquely identify a row. So in your OneNote document here, let's see where we are. On this keys slide, if there's anything that you want to add in there, while it's kind of clear in your head, do so. I'll put this on the Zoom session for you if you want to do a snip or something of this video. So Mr. Fountain, David Fountain here, was just working on preparing to teach his 3D animation class and working on his teaching his database class, and I like the way he combined the two. So he came out with some cute stuff. So our primary key, super important, super important. Way back, I remember when I first started teaching, and the business teacher was teaching Access, how to use Access database, and students were asking me questions about it, and she did a great job. She always did a really awesome job. But they never used a key. They never went set a primary key for any table. It wasn't in the book. It didn't say that you need to. She didn't have any sort of background, so she didn't know that it was important. Super important. I mean, when we're using a small little Access database, it's not the end of the world. But if I start looking through millions and millions of rows trying to find a specific order or something like that, then that primary key becomes very, very critical. Get to the right order, get to the right customer, or whatever it is that I'm wanting to find. So we have a couple of other terms here. Let me jump around someplace else before I get back to this. This is the textbook. So not much different than the online version. And the thing I wanted to bring up were these definitions over here, because they have a whole bunch of them in our book. And they're kind of just hidden in little different areas. But we saw that a foreign key is unique across a table. When we're using that foreign key, or I'm sorry, primary key, when we're using that primary key in another table, it becomes a foreign key. When we're working with foreign keys, we get concerned about referential integrity. If I have a new employee, and in my employee table, I have a foreign key for department number. When I get that new employee, do I have to know what their department is before I can ever add them to the table? Or can I set them up with it blank and then come back and decide later what department they're in? Not a big deal to us, right? But a big deal to the human resources department, depending on how things are set up. That is a decision that impacts referential integrity. If I say that that department number has to be assigned when I create that employee, I'm going to say that there is a referential integrity rule set up in that relationship that says I can't have an employee without a department. If I decide that I can leave that blank, then I've decided I don't need to enforce referential integrity between those two tables. There is a relationship, yes, but it's not enforced. Does that make sense? Now, I still am going to make sure that if I try to put data into that column, it has to be a valid department number. The database management system will continue to make sure that field is valid in that way, that that data does exist. So besides our key fields, we mentioned we could have other data types that are important to us, like the last name. Those would be secondary keys, things that are important to us, but we wouldn't be able to use them to retrieve a specific row of our data. Because with, like we've seen with last name, we could get 7 rows back if we choose to see all of the employees whose last name is Smith. We need those secondary keys though, and we need to know that they're in the database, because our business function might involve people calling in and they might not know, like in their example here, they might not know what their customer number is, but they know the name of their company. So we have to have those secondary keys to look things up like that, to even find that primary key, because sometimes our primary key is just a meaningless bunch of numbers to be unique. Okay, so some other terms. Is the more you get into the computer field, the more you'll realize that sometimes the big difference between products is just the terminology. And some companies like to come out with a new product that's different from the other product, and really the only thing that's different is what they call the thing. And we have to deal with it, because now we have the same term that means all these different things, or many different terms that mean one thing. So a super key is another term for a primary key. So a super key is an attribute or combination of attributes that uniquely identifies each row. A candidate key is, let's read this definition here, a minimal, irreducible super key. So it's a super key that does not contain a subset of attributes that is itself a super key. So what are they saying there? They're saying like customer number is a super key, it's a unique key, it's a primary key. It's also a candidate key because it's not made up of other things, right? So if I used a phone number as my primary key, that would not be a candidate key because it could be made up of the area code and the rest of the number. So since it's 2 pieces of data put together, it is a subset of attributes, so it can't be considered a candidate key. So just a really small difference to make it a little bit different term. And that's important when we're designing databases, all of these things. Now, a primary key is a candidate key selected to uniquely identify all other attribute values in a given row. A foreign key is an attribute in one table whose value must match the primary key in another table or be null. And finally, a secondary key is that name or whatever other data items we want to use to be able to get to data. So when I was thinking about this morning or last night, I was thinking, what's some really big database things that are going on right now for us? Well, the census, right? That's a pretty big database that we create every 10 years in our country. So what would be a good candidate key? What would be the ultimate key for the census? Think about it. What do they use? Seems like they use address, don't they? Because if they haven't heard back from an address, they send someone out. So just think about that. How would you set up that data relationship? It only happens once every 10 years. They probably get to redesign each time. Are they going to question? We know that the questions are different. So how would you save that data? Be thinking about it and all the different keys that are available and how you would use those. So I don't think there's a right answer. It's just something to really ponder and think about. So I have all these rules that have to do with keys. And we mentioned referential integrity as being the integrity that says my reference to another is good. I have a good reference. I know how to access that other data. So we can have some other integrity rules besides that reference integrity, my reference to another area. Some other things that we can do, let's take a look at these within an entity itself. So within all of our students, we want to make sure that we have integrity. And that means all of our keys are unique. We don't have any key parts that are null. Why we need this integrity? So that each row will have a unique key that we can locate. And their example here is we can never have a duplicate invoice number. How would we know what bill we sent out if we had duplicates? And then referential integrity is that integrity where our reference to another row in another table. So we can say a foreign key can either have a null entry or an entry that refers to a mapping primary key. So their example, like our department example with an employee, is that we might have a customer that doesn't know who their sales rep is yet. When we do assign a sales rep, it better be a valid sales rep, but not having one assigned is okay also. And that's a decision we make when we design the database based on our business rules. Here's our picture there. So we have entity integrity within our customer table because we don't have any duplicate keys. And then we have referential integrity where our customer table has an agent code that refers to an agent in the table or is empty. So in this case, we have entity integrity and referential integrity. Now, what's this one? This is an interesting concept. They say that sometimes we don't want to deny that referential integrity. We want to go ahead and say there cannot be a customer without an agent in the table. But we'll set up like a dummy agent, like a dummy row out there in our agent table. And so if we don't know who the actual agent is, we'll use this dummy variable with our agent code until that gets assigned. And then we could run a list of all customers that are assigned this agent code -99, and we'd know which customers need to have agent numbers assigned. So this is a cleaner way of doing it, where we are putting that referential integrity rule in our database, saying no customer can be created unless they have an agent code. But then we're saying, but if the agent code hasn't been assigned yet, use this -99. This will be our dummy code. Does that make sense? So that's something that we do all the time. And that's a thing that would have to be a business rule, right? That needs to be written out in our rules, because if we don't keep track of that information, it could easily get lost between the design and the development process of our application. Okay, so relational algebra. That's what we're really working with here with our database. We have, each of our tables is a set of data. So when I look at my student table, all of the rows within my student table are my set of student data. So I could have, specific rules about that data, whatever I'm working with, but all of the set theory that comes with relational algebra, which is a great math area, is going to apply to that set. So let's get some definitions down. Relational algebra is just a theoretical way of manipulating table contents. So it's because we're working with tables and relations, and we sometimes even can see that those terms can be used interchangeably, we have a special type of variable called a rel var, and it's a variable that holds a relation. So they give you an example and they say, if you're writing a program, you might use a variable named qty for holding an integer data. The variable qty is not an integer itself, it's just a container for holding integers. It's just a spot in memory. Similarly, when you create a table, the table structure holds the table data. That structure is properly called a rel var, and the data in the structure would be a relation. So that rel var, that variable, is a container for holding all of the relation data of the table. So when we look at a variable like that, we're going to have two parts, the heading and the body. The heading contains the name of all the attributes, like all of our column names, and then the body contains the actual data. To maintain the distinction in formulas, we will use some specific terminology, a lowercase r, an uppercase r, to signify these relations in our relational algebra. So we're really at a good stopping point here. So we're at 3-4b, talking about relational set operators. Read through this material before next time so that we can talk about it and we can look at some different visuals of the different relationships.